we're going to look at several functional groups in Chapter 12. In Chapter 12, we're going to look at several functional groups that have oxygen and sulfur in them, but primarily oxygen. There's alcohols, ethers, ketones, aldehydes, and then the one functional group that has a sulfur in it, thiols. Alcohols contain oxygen, and what they have in them is a functional group that is the hydroxyl group, or as many of you would term an OH. Ethers have an oxygen with 2 carbons attached. Thiols look just like an alcohol, but instead of an oxygen, there's a sulfur. Aldehydes and ketones have oxygens in them, but they have a carbon-oxygen double bond. The difference between an aldehyde and a ketone is that carbon-oxygen double bond, or carbonyl as we call it, is at the end of a chain in an aldehyde, and in a ketone it's in the middle of a chain. Now, alcohols have this hydroxy group, and that hydroxy group, or hydroxyl group, can be on different types of carbons. Now, some carbons are at the end of a chain, and they only have one other carbon attached to it. When that happens, we call them a primary alcohol. So, a primary alcohol has one or less carbon attached. That hydroxyl group can be in the middle of a chain, and the carbon have 2 carbons attached. When that occurs, we call it a secondary alcohol. And then if the carbon has 3 carbons attached to it, and there are no hydrogens on that carbon, then we call it a tertiary carbon. If we look at this molecule down here, you can see in blue the alcohol group, the hydroxyl group, is on a carbon that's at the end of a chain, and only one other carbon is attached to it. The alcohol that is in red is in the middle of a chain, and 2 carbons are attached to it. And then the alcohol that is in green is at basically a T, because the carbon that the hydroxyl group is attached to has 3 other carbons attached to it. Now, something that you've already learned a little bit about this, but you just didn't know they were called alcohols, is that alcohols can hydrogen bond. Remember, the alcohols have this hydroxyl group on them, which have an oxygen-hydrogen bond. Anything that has an oxygen-hydrogen bond can hydrogen bond. So they can hydrogen bond to each other. When they hydrogen bond to each other, that's a strong intermolecular attractive force, and alcohols that have the same molar mass as alkanes have much higher boiling points and melting points than those alkanes. The hydroxyl group makes them stick to each other so that boiling points and melting points are higher. Again, that hydroxyl group makes it so that alcohols have some water solubility. Now, one little hydroxyl group and many, many carbons will not make that entire molecule soluble in water. But the book says if you have 6 carbons or less, that the compound will be water soluble if there's a hydroxyl group. That's really a little bit pushing it, because you're going to have very limited water solubility. Yes, there will be some water solubility, but if you were to put a couple drops in a milliliter of water, you would not observe any of it noticeably dissolving. So really, I prefer to say a smaller number of carbons per hydroxyl group. 3 or 4 is more closer to what you would say makes a compound soluble. So if you have a compound that has 8 carbons and 3 hydroxyl groups on it, you would expect it to be water soluble. Now, we can name alcohols in the same method that we've been naming compounds prior to this. You first count the longest chain in the molecule, count the number of carbons in the longest chain. You select the proper prefix based on the number of carbons. You take the E off what would be the alkane. So if, let's say, there's 7 carbons, if it was an alkane, you'd say heptane. You take the E off and add OL if it is an alcohol, so it becomes heptanol. You must number where that functional group is, so you would put a number in front of the name to say where in that chain is the hydroxyl group. Now remember, you have to take the lowest numbering system, so you check by numbering from either end of the molecule to see which one gives you the lower number. And then you locate substituents, name, and number them. Here are 2 examples. The first one on top, if we look at the longest chain, remember you have to go from a CH3 to a CH3. So if I look at the longest chain here, I will see there are 7 there. CH3 in the beginning, go along all the way until you get to the alcohol group, the hydroxyl group, and then drop down to the 2 carbons below, and that is your longest chain. So that would be called hept, and then we would put enol on the end for the alcohol group. Now where is that alcohol group? If I count from the left, I would find it's on the number 5 carbon, and if I count from the right, I find it's on the number 3 carbon, so I call that 3-heptanol. I then see that there are 2 substituents, 2 methyl groups. One of them is on the number 3 carbon, and one of them is on the number 5 carbon, so I name it 3,5-dimethyl 3-heptanol. If I look at the example below, you will see there are 8 carbons in that ring. So that would be cyclooctane. But it has an alcohol group on it, so I take off the E and make it cyclooctanol. Remember, in the rings, the functional group always is on the number 1 carbon. So I will number the ring according to that being on the alcohol being on the number 1 carbon. We don't have to say the alcohol is on the number 1 carbon. That's assumed. So all we have to do is number the substituents, and we can see that that is 2-methyl. So it's 2-methyl cyclooctanol. Here are 2 problems for you to try. The top one, notice it has 3 hydroxyl groups, so you're going to put triol on the end. The bottom one is a little bit more straightforward because there's only 1 hydroxyl group. Both of them are alcohols. Find the longest chain, name and number the functional group, and then the substituents. If I look at this compound, I count the number of carbons in the longest chain, and you see it is 3, so we would say propane. And because there are 3 alcohol, propane triol. Now we have to number where those are, and if you look at them, it doesn't matter which end you start on, they're on 1, 2, and 3 carbons, so it's 1, 2, 3 propane triol. And the reason I brought this one as an example is I wanted you to see this. This is an important biological molecule, also given the common name glycerol. So glycerol and 1, 2, 3 propane triol are compounds that we will see in the future when we look at biological chemicals. Let's look at the next example. The longest chain has how many in it? Remember to go from a CH3 to a CH3, and you can see that there are 8 carbons in the long. So that is going to give us a octanol. It's octanol because we have the hydroxyl group there. Which end of the chain gives us the lowest numbering system? It would be starting on the left and going to the right to number them. So octanol. So now I have the substituents to locate. I can see there are two methyl groups. One of them is on the 5 carbon and one of them is on the 7 carbon. So I'm 5,7-dimethyl 3-octanol. And if you notice the way that the dashes are, I will not be taking off for missing a dash or two, but we put dashes after our numbers, and if there's a number in the middle of the name, we put a dash before it also. Let's look at some of the common alcohols that we have. The 1-carbon alcohol that we have is methanol. It's also called methyl alcohol. That's a common name that we have for it. An old-fashioned name for it is wood alcohol because it is obtained by the fermentation of wood. We also have ethanol. And remember, we can write this in two different ways. We can write it HO, CH2, CH3, or we can flip it over and write CH3, CH2OH. Both of those are correct. A common name for this is ethyl alcohol or grain alcohol. And why is it called grain alcohol? Because it is produced by the fermentation of grain. If I look at the next compound, there are 3 in it, so that becomes prop, and it's propanol. The hydroxyl group is on the number 2 carbon, so it's 2-propanol. This compound you can find on the grocery store or drugstore shelf. Another name for it is isopropanol, and the name that you're going to find on the bottle usually will be rubbing alcohol. 1,2-ethane-diol, which we see at the bottom here, it is a glycol. Glycols are diols. That's another name for diol. This is also called ethylene glycol, and you may recognize that name because we find it in antifreeze. When you put it in water, it lowers the melting point and raises the boiling point of water, and it is effective as an antifreeze in radiators.